Hey everybody, Matt Morgan here. We're going to talk about question 3 in the recitation exercise 9. So here's the question. They want to determine the wavelength of light emitted when an electron goes from n equals 5 to n equals 2. The handout background doesn't show much how to do it, but the textbook does. So that's why I'm doing this video. Now I'm going to demonstrate the calculations going from 6 to 2 while the question is 5 to 2. Don't just go to the end of the video and copy my final answer. You'll get it wrong. The purpose of this is to show you how to do that calculation. So the textbook uses a formula, or OpenStax. It relates the transition between energy levels to the wavelength. Super handy. So here's the formula. 1 over that wavelength equals a constant R infinity times 1 over n1 squared minus 1 over n2 squared. So let's define these terms. For this example, n1 equals 2, n2 equals 6. For the problem you're doing, n2 will be 5. The R infinity is a version of the Rydberg constant. It's 1.097 times 10 to the 7 reciprocal meters. The derivation of this is really cool, but well beyond the scope of the course and the exercise that you want to do. So the wavelength that we calculate will be in units of meters. They ask for nanometers, so we'll have to do that conversion at the end as well. There's our formula. I've plugged in my constant. I've plugged in my two values. Now the rest is just math. I'm going to evaluate the inside of the parentheses first and multiply by the constant. I get 1 over lambda equals 2.4278 times 10 to the 6th. Try that calculation yourself, and then of course be sure to plug in n equals 5 for the exercise. Now what I'm going to do next is invert both sides. The beautiful thing about algebra is I can do whatever I want as long as I do the same thing to both sides. Lambda will have units of meters, and that number converts to 4.10 times 10 to the minus 7th. We're almost there. We have to convert meters to nanometers. Okay, there's our wavelength in meters. We need to convert to nanometers. We'll set up a small dimensional analysis grid. Our conversion is 1 times 10 to the 9th nanometers equals 1 meter. Multiply those two numbers, meters cancel, I end up with nanometers. The answer is 410 nanometers. So do the same calculation for the 5 equals 2 transition, and you will have the answer you need. As always, let me know if you have questions.